All right, guys, in this lesson we're going to be looking at type 1 and type 2 errors, and our objective here is just to interpret a type 1 and type 2 error in context and give it a consequence of each. So in order to really understand this, let's establish a significance test through this example. So during the winter months, the temperatures at the Colorado cabin owned by the Starnes family can stay well below freezing, 32 degrees Fahrenheit or 0 degrees Celsius. For weeks at a time, to prevent the pipes from freezing, Mrs. Starnes sets the thermostat at 50 degrees Fahrenheit. The manufacturer claims that the thermostat allows variation in home temperature of a standard deviation of 3 degrees Fahrenheit. Mrs. Starnes suspects that the manufacturer is overstating how well the thermostat actually works. So, first, we would need to identify our population and parameter. And our population is the temperature variation inside the cabin with the thermostat set at 50. Our parameter is the mean standard deviation in the temperature. So really we're focusing on our standard deviation, or this number right here. If we were to state null and alternate hypothesis in words and symbols for that, we would say that our null hypothesis is that the standard deviation in temperature of the house is equal to 3. So the temperature really only varies by about 3 degrees, or at 3 degrees exactly. Our alternate hypothesis would mean that they're actually overstating that, or that the standard deviation is actually greater than 3, or the standard deviation is greater than 3. The temperature is greater than 3, varies greater than 3, sorry. Then if we were going to establish significance levels for that specific test, we would say, and this is just two examples of significance levels that we could personally set for this specific test. So our first one would be that alpha is equal to 0.05. And what that means is that the thermostat keeps the temperature within 3 degrees approximately 95% of the time. So about 5% of the time, it actually would not keep the temperature within approximately 3 degrees. The second significance level would be alpha is equal to 0.01, and that would mean almost the exact same thing, other than it means that the thermostat keeps the temperature within 3 degrees approximately 99% of the time, or there's about a 1% chance for failure in this case. So given the result of the test is P is equal to 0.0431, what conclusion can be made at each of the significance levels above and interpret the P value in context? Well, if the temperature stays within 3 degrees of 50, we would only see this result in 4.3% of all samples of the same size. So if we set our significance level at 5%, since our P value of 0.0431 is less than 0.05, we would reject the null hypothesis, meaning that there is convincing evidence to believe that the thermostat maker is wrong about its reliability. If we were going with the significance level at 1%, since our 0.0431 is greater than 0.01, we would fail to reject the null hypothesis, meaning that there is not convincing evidence to believe that the thermostat maker is wrong about its reliability. So all that's to really say, and if you can kind of remember this, is that if our P value, is less than alpha, then we would reject our null hypothesis. If our P value is greater than or equal to alpha, then we would fail to reject our null hypothesis, or we would say there's not enough convincing evidence to believe that whoever came up with the null hypothesis is actually wrong in this case. So all of that kind of leads to this idea behind type 1 and type 2 errors. So at the significance level of 0.05, in that example that we just went over, we rejected the null hypothesis because our p-value was less than that. However, what if our p-value was actually greater than that? What if the thermostat really does keep the temperature within 3 degrees? Well, what would have happened at that point is we would have made a type 1 error. We would have rejected a true null hypothesis. If we look on the other side of that, at the significance level of 0.01, we failed to reject the null hypothesis. However, what if the thermostat really does not keep the temperature within 3 degrees? And in that case, we would have made a type 2 error, and we would have accepted a false null hypothesis. So all of that's really to say, and actually I'm going to move on to this slide because this one has a little better information. You have two possible outcomes about the population. You have two possible outcomes about the truth about that, and you have two conclusions that can be made based on your sample or based on your study that you created. The first truth about your population is that your null hypothesis is true. The second one would be that your alternate hypothesis is true. So either one of those would be the case. The conclusions based on that sample, the first one would be that we would reject our null hypothesis. Our second outcome would be that we would fail to reject our null hypothesis. So really, this visual right here is super helpful in trying to determine what is a type 1 error and what is a type 2 error. If your null hypothesis is true and you reject that true null hypothesis, that's what's known as a type 1 error. You'll notice that if our null hypothesis is true and we fail to reject that null hypothesis, that's just a correct conclusion because we're not rejecting it and it actually was true in that case. However, if our alternate hypothesis is true and we reject our null hypothesis, that's also considered a correct conclusion because we're not accepting whatever the null hypothesis was. However, if our alternate hypothesis is true and we fail to reject the null hypothesis, meaning that we accept the null hypothesis, that's what represents a type 2 error. So really getting that visual down is super important in determining what's a type 1 error and a type 2 error. You can also remember a type 2 error is when you fail to reject, basically. So we know that it's going to be on this row right here, failing to reject a null hypothesis when the alternate hypothesis was actually true. Let's look at this example real quick, which is one that we've looked at in the past. A company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. The company selects a simple random sample of 15 new batteries and uses them continuously until they are completely drained. The sample mean lifetime of that specific sample is 33.9 hours. So a significance test is performed using the hypotheses that the null hypothesis is actually the mean lifetime of that battery is actually 30 hours. The alternate hypothesis would be that the mean lifetime is actually greater than 30 hours. So where mu is the true mean lifetime of the new deluxe AAA batteries, the resulting p-value for this is 0.0729. So a type 1 error in this case would be to reject that the battery lasts 30 hours in favor of them lasting longer, when in fact the mean time was actually 30 hours. Again, that's accepting the fact that the null hypothesis is actually true, but rejecting that true null hypothesis. A type 2 error in this case would be to fail to reject that the battery lasts 30 hours, so accept the fact that it actually does last 30 hours against the claim that they actually last longer, when in fact they do not last longer. Or they do last longer, excuse me, sorry. So a consequence of a type 1 error in this case would be to move to the new battery when the old version of the battery works just as well. The consequence of a type 2 error in this case would be to stick with the old battery when the new battery lasts longer, in fact. So when we're looking at this idea of type 1 error probability, what is the probability that we will make a type 1 error? So what does a 95% confidence level mean? Well, that just means that we are 95% confident that the true parameter is in the range of whatever we specified. The complement of that, or the flip side of that, would be that there's a 5% chance that is actually not in the range. So what is the probability that we will get a value that causes us to reject a valid null hypothesis? And that's what's known as our significance level. Again, the probability that we will get a value that causes us to reject a valid null hypothesis. So the significance level, and this really plays into that, at alpha of any fixed level test is the probability that a type 1 error occurs. That is, the significance level is the probability that the test will reject the null hypothesis when the null hypothesis is actually true. And then we want to consider the consequences of a type 1 error before choosing a significance level. So we want to basically consider what the actual consequence is before we decide to set that actual significance level itself. So if we're looking at, just to kind of give a visual representation of this, if we looked at this example right here for type 1 error probability, for the truckload of potatoes in the previous example, we were testing our null hypothesis at the proportion being at 8%, with an alternate hypothesis that our proportion is actually greater than 8%. So where P is the proportion of all potatoes with blemishes in a shipment, we want to suppose that the potato chip producer decides to carry out this test based on a random sample of 500 potatoes using a 5% significance level. So all of that's really to say is that if we saw this graph right here, this graph represents a sampling distribution that, given that our null hypothesis is actually true. And so it's a sampling distribution of that the probability for that sample itself. So if that's the case, what you'll notice is that this is representing about a 95% confidence level, which means that there's about a 5% chance that we actually hit a type 1 error. So if our null hypothesis is true, then a decision to reject the null hypothesis based on the data is a type 1 error. So this would mean that we would get a number that causes us to reject that true null hypothesis, and that's essentially what's representing the probability that we actually make that error. Well, the probability that we actually make that error is controlled by that significance level value. So really kind of the important thing to note here is that if your significance level goes up, that is going to make the probability that you will make a type 1 error go up as well. So that's the main thing that you kind of need to focus on, is that our significance level controls the probability that we will make a type 1 error. The higher our significance level goes, the higher our probability for a type 1 error will actually become, which means that we are going to reject a true null hypothesis in this case.